Welcome to DotNext. I'm thrilled to be here. This is my first time in Russia. I understood absolutely none of what was said. I should apologize in advance, by the way. If I fall asleep during my own talk, please throw things at me to wake me up, and then blame Dustin Campbell and the rest of the Roslyn team. I had a lovely and extremely large speakers dinner last night, and then got back to my room and played with Roslyn. And at 1 o'clock, half an hour after asking a Stack Overflow question about Roslyn, I went to bed, and then I heard my phone buzz at some point that said, "Oh, you've got an answer." I read the answer, went back to bed, and then about an hour later thought, no, I can't possibly stay in bed. I've got to get back to coding. So I've had about 3 hours sleep, and it's all Dustin's fault. That's the important thing to remember, okay? Whatever goes wrong, it's Dustin's fault. Anyway, back to today. So I was asked to keynote, and it's very difficult to keynote a conference that says it's really deep technical content, because keynotes tend not to be deep technical content. I hope you'll find the presentation deep in a different way. You probably won't learn much on the technical front, but I want you to think about the problems that I'm presenting and the way we have all messed things up, basically. So don't necessarily focus on the details. Think about the attitudes of all the people involved and how everyone's been trying to do the right thing and it's all gone horribly wrong. So just to introduce myself and my co-presenter, I'm Jon Skeet, as you probably know. I work for Google in London, and for the last couple of years, I've been working in C#, which is fantastic. I've previously been doing Java-y kind of things, and oh, it's so nice to be back in C#. Basically, my job is to make the Google Cloud Platform rock for C# developers. You know, I view it as I have two jobs. If you're a C# developer looking for a cloud platform to develop on, then you should clearly choose Google Cloud Platform because of the work I've been doing to make it just a beautiful place for you to be. On the other hand, not to sort of eat my colleagues' lunch too much, but if you're already bought into, I want to be on Google Cloud Platform because of the amazing services and all kinds of things, and you're thinking, which language should I use? Then again, you should obviously choose C# because it's an obvious, wonderful language, and the work I'm doing helps make it a beautiful place on GCP. So that's my day job, and this is Tony the Pony. Tony is not a very good developer. He tries hard, his heart's in the right place, sort of about there, I guess. But basically, there are many forces ranged against Tony that are trying to cause him trouble. And you see, the problem that Tony has and that we all have is we're trying to do awesome things. We're thinking about HoloLenses or all kinds of amazing platform services on GCP or whatever you're doing. I'm sure that every single one of you is doing something interesting and fantastic. But that's only going to work if you've got a solid foundation. And we have really screwed up numbers and text and dates and times and many other things, but I'm just going to focus on those three areas today. And really think about how it's amazing that anything works at all, given the awful mess we've made of things. So there are things that really ought to be simple, but we've managed to make them complicated. So time and time again, we end up with this face when we're doing something that should be really, really simple and isn't. And my job in this talk is to distribute the blame for all of this with three groups of people. Firstly, there's the user. Okay, the user has simple intentions. They know exactly what they want to do. They will give you some requirements, maybe, if you're lucky, and sooner or later you will find that there are just some ambiguities or some conflicts that the user doesn't think of as a conflict because they hadn't thought of the case where you're stuck in a lift and you need the toilet and there's a fire alarm going off or whatever it is. The kind of corner cases that we're paid to think about, they will dismiss as, that's never going to happen, but we've still got a code for it. And the other problem is, having one user is easy, because they can make assumptions about the way the world works, and you can write code that kind of mirrors that. Unfortunately, as soon as you have more than one user, you will have conflicting requirements. They will both think that their answer to whatever question you ask them is obviously correct, and they'll both be different. So, as an example, in dates and times, so if you have someone who is born on February the 29th, okay, in the year 2000, then suppose on 2018, it is February the 28th, and there's an election, and they can vote if they're 18 years old, and they can't vote if they're not. Are they 18? Well, if you do arithmetic and say, well, I will add 18 years to February the 29th in the year 2000, then you end up with February the 28th in 2018. So clearly they're 18. On the other hand, you could say, well, February 28th is earlier than the non-existent day of February 29th, so no, they should have their birthday on March the 1st, so they can't vote. And both of the people who put those different viewpoints will say they're obviously right. So I blame users. I also blame architects. Okay, so they're stroking their beards. I'm not sure what the equivalent of stroking beard is for female architects. If anyone has any ideas, let me know. But anyway, so they're stroking their beards, thinking, okay, the users have made the world very complicated. I will model the world in a different way. What do they come up with? They come up with something, a model, that is just as complicated as the original system, but subtly different. And then there's us, the poor schmucks who have to code to this, who might have some idea of what the user wants, some idea of what the architect expected, but not the whole picture. So typically, we don't understand every bit of the user's intent. We almost certainly haven't read all the documentation that the architect has given, or the author of a library or whatever. And even when we do know that, we make mistakes because we're human as well. So we mess things up. So those are the three categories of people that I'm going to blame, and let's see what can go wrong. So let's start with numbers. If you ask a person in the street, what are computers, what do they fundamentally deal with? I suspect they'd say numbers, and they'd be right. Everything else is built on numbers. So we should have those pretty much down and understood, right? And it's not too bad for integers. But, I wrote this deck originally, 4 years ago, at least? And back then, no, I think it was 6 or 7 years ago, and there were already hundreds of questions on Stack Overflow saying, why does double arithmetic in .NET not work properly? Why is it broken? And I blame evolution. This is the problem. We have 5 digits on each hand. So we have a total of 10 digits. And this is a mistake, and it's led to great suffering. Life would have been much better if we'd been like this. then we would naturally count in base 8, and things would be significantly better. We'd cope with binary reasonably naturally. The other solution is we could just ignore our thumbs and, count 1, 2, 3, 4, 5, 6, 7, 8, and then go on. But no, we've gone with 10, and that's where all the problems started. Okay, Tony, this is where you're going to start to shine, I'm sure. So here's a little puzzle for you. Have a look at this bit of Java. Okay, and I want you to tell me the value of D. Tony doesn't know Java. Okay, here's the same in C#. Okay, Tony's quite excited. Right, okay, Tony thinks the value of D is 0.3. Sorry, Tony. Fail. You were close. You were very, very close. But the actual value, which, maybe I wouldn't have expected you to know completely off the top of your head, is this. Now, that is the absolutely exact, assuming I copied things down correctly, which isn't really a given, value of D. You will have seen, I'm sure, maybe you will have written, that double values aren't exact, they're just approximations. How many of you have at least seen that? Yep. And how many of you have also seen things saying, you should use decimal because decimal values are exact? Yeah? Okay. I don't want to get too political in this talk, but what we're all suffering from is unconscious bias. Okay? Normally, we associate unconscious bias with sexism and racism, etc. But in this case, we have decimalism. We have a natural assumption that decimal numbers are better than binary. If you look at the details of how system.decimal and system.double work, they're really, really similar. They're basically an integer shifted left or right for a point. And that point can be a binary point or a decimal point. That's all there is to it. Not quite. There's denormal numbers and infinities and preservation of zeros for decimal but not for double and all kinds of little bits. But the idea that somehow decimal is precise and double isn't is a complete myth. We get lured into it because our source code has decimal values. Yeah? The 0.3. That's naturally decimal, and there is an approximation, but it's at compile time, or it's when arithmetic gets performed. There's the exact value. If say you're adding two double values, there's the theoretical exact value, and then there's as close as you can get to that and represent it in a double. So there is an approximation, but then the exact value is stored. The exact value that's as close as possible to the real value. And if you doubt that that happens in decimal, try dividing 1 as a decimal by 3 as a decimal. You will not get exactly a third, because that can't be represented as a decimal. Okay, I've probably banged on about this for too long now. But you see the problem. Even people trying to help and who have a reasonably good idea of at least why D isn't exactly 0.3, when they're trying to help, then give subtly the wrong impression. We're in a world of pain. So why is this important? Well, because we can have different values, and the two 5.50s here are different. 5.5 kilograms is never going to be exactly 5.5 kilograms. It doesn't really matter whether we represent it in decimal or binary. It's always going to be an approximation. We can store a precise value, but that won't be precisely the mass of anything, if you follow. Whereas I can have exactly £5.50, or whatever the ruble equivalent would be. Of course, if I tried to convert this into rubles, the exchange rate would probably give me an approximation. So even when you start thinking, well, currency values are always exact decimal values because they're man-made, they're unnatural values, as soon as you start doing arithmetic on it, you're still going to have the same problem. Okay, so hopefully I've convinced you that we have messed up numbers. Let's deal with text. So, fun story. Hopefully you recognize this lorem ipsum is typically what's written to demonstrate typography, apart from anything else. The first time I wrote this out, I missed out the ipsum. Of all the words to fail to put in, if you're going to write lorem ipsum out, you've got to get lorem and ipsum. After that, no one's going to notice, but they'd notice if you missed the first bits. So, text. We know that computers run on numbers, but the rest of the world pretty much runs on text. So, if we've messed up numbers, at least we can get text right. Oh boy. So, actually, I first gave this talk in London, where most people were probably natively British. My guess is that all of you have much, much more experience about the pain of this than I do, because I deal with mostly ASCII text all day. These are a few random katakana characters. I hope they're not rude. And over on the left, we have people speaking bits of ASCII. But basically, cultural diversity, much as I love it, has screwed over computing again. If we could all just agree on one character set, one fairly small, ideally, character set, I don't mind if it's not ASCII. If the rest of the world decides that they want to use Chinese or Cyrillic or whatever it is, that's fine. But could we please all use the same characters? So, we have problems. I'm sure all of you have run into problems with files being encoded incorrectly, or people using encodings when they shouldn't. The number of questions on Stack Overflow where someone's saying, I've got this binary file, it's an image, or it's the result of encryption, and I'm storing it in a string, and immediately sort of warning, awooga, 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 something's going to go wrong. In fact, I know exactly what's going to go wrong. You are losing data. The number of problems I see on Stack Overflow is immense. So, okay, we know we've got encodings as a problem, but let's assume we're all using UTF-8. We're all using Unicode. We can encode anything we like. Does that mean, everything is actually done and dusted? So, yeah, some people need to catch up. But at least it's simple now because we've got Unicode, right? Let's put that theory to the test. So, Tony, I would like you to write some code to reverse a string. Okay? He's very quick, especially as you've seen in the code already, but there we go. So, there we go. Okay, well done, Tony. It's not awful. He's not done repeated string concatenation, but I'm afraid it's still wrong. Let's see why it's wrong, and then we'll get down to just the depths of how wrong it can be. So let's take one of my favorite musicals, Les Miserables. So we could write it in the top form, with the E with an acute accent as a single character. Or, and I think you can see where I'm going here, we could write it in a different normalization form with an E followed by, not preceded by, I'll come to that in a minute, a combining character, this U0301 that's hex. That's the combining character for acute accent. So what happens when we run Tony's code on that bottom string and then print it out, and when we print it out, we expect the wonders of Windows or whatever it is to put the combining character on the text. We end up with the acute on the R, because if you look at this, if we go backwards from S, we end up with R followed by the acute. I said that the acute comes after the character. When I first gave this talk in London, I messed it up. I had the combining character before the E. And you know why? I had been somewhat diligent. I couldn't remember whether combining characters went before or after, and I did a little bit of research and I do find the Unicode documentation quite hard to navigate. It's probably just me, but I find it difficult. So I thought, I'll just try it and see. You know, I can come up with that string really easily. I can hard code that as a text literal, string literal. So I wrote a little WinForms app, and boom, when I put the combining character before the E, it put the acute on top of the E. Because I had handwritten this code, so Windows Forms had a bug in it for a long time, which used the combining character in the wrong place. If you start a WinForms app in Visual Studio, it automatically puts something like use text-compatible rendering or something false. In other words, put me in do the right thing mode. As I've written this in a little text editor, I didn't get that, so I got the broken original form. So that's why I ended up with something that effectively had the acute on the I to start with. But I don't say this just to blame the Windows or WinForms folks. It shows a problem. The people writing the rendering are meant to be experts at this, and they screwed up. What chance have we got? Bear in mind, and I really want to emphasize this, how many of you is it your job to understand Unicode really thoroughly? Exactly. You shouldn't have to think too hard. If you have to learn all of that, if you have to be aware that Windows Forms does the wrong thing unless you call something, things are broken. And that's not your fault. It's your fault when you don't read the documentation or whatever. That's a different matter. We've all got blame to share. This is only one way that normalization messes things up. Imagine you have a name field in some application. Don't care whether it's web or whatever. And you have a maximum length. And maybe that's being enforced in the database. This is getting worse. How are you going to find out how long the string is? So you've got the string from the user, however it is, WPF or ASP.NET Core, whatever it is. How are you going to find the length of a string? Tony, you use the length property. Right. Can anyone tell me things wrong with using the length property? Or at least concerns? Yeah. You're sort of on the right lines. So the gentleman said that a char is 1 byte, and in different encodings, things can end up being longer. A char in .NET is always actually 2 bytes. It's always a UTF-16 code unit. So almost everything is encoded as 1 char. On the other hand, how many characters does this eacute count as? Is it 1 or is it 2? If we've got that string, the length will count it as 2 characters because it's 2 UTF-16 code units. So you could have 2 users with the same name whose browsers happen to use different normalization, and one of them can put their name into your web app, and one of them can't. That feels broken to me. Next, there's Emoji. I said most things can fit into a UTF-16 code unit. as soon as you get outside the basic multilingual plane, you do have the problem of variable width, in that a bunch of characters, emoji being the most commonly used ones, will be two chars, two UTF-16 code units. Maybe. So you've already got the problem of, if someone wants to put in their name as 30 emojis, your .length property usage will already have messed them up, because it will tell them that, or it'll tell your code that it's got a length of 60. But it gets worse than that, because you can have combining characters for emoji as well, for skin tone. So if your emoji name is 30 times smiling face with an Asian skin tone, that's going to be 120 characters. And that's what .NET will tell you. Out of interest, does anyone know, assuming that some of you are still using SQL databases of some form, when you specify a maximum length on a field in your particular database, do you know what that means? How many of you believe you know whether it means the number of bytes in some specified encoding, maybe it's the number of bytes in UTF-8, or the number of UTF-16 code units, or the number of Unicode code points, or the number of Unicode code points in a particular normalization? If you don't know that, then you don't know what a maximum field length means. That's kind of worrying, isn't it? We've messed up text. And we don't even have to go as far as accented characters or emoji or anything. Let me show you two characters to strike fear into the heart of all developers. How many of you have had problems with Git and line endings? I have no idea what that auto-crulf configuration option means. I've read the documentation many times. I have never understood it. I've particularly never understood what I ought to do to make things work again. I've ended up in situations where I've got code that I've run some code generator, and I do a git status, and it shows me all these files have changed. And I say, okay, git diff, nothing. Git commit, nothing to commit. Hey, you just told me they have changed. So, we have /n on Unix and /r/n on Windows, and I think just /r on Mac in some forms. And the Unicode folks, in their great wisdom, said, you've got all these three formats. We should really standardize on this fourth one. We will solve it by introducing another line-breaking character. Oh, boy. I want to show you a bug that I wrote. So, Tony, this is your chance to laugh at me. I wrote this bug 20-something years ago. Yeah, you've seen the talk before. You know what's wrong. Anyone venture to guess what happened with this? Sorry, it's Java. Yeah, so there's already pain. But apart from that, what's the actual bug? Turkish! Well done. If I had prizes, you could have one, but have my warm regards. This fails in Turkey. So I had a header somewhere, or a property file, or something like that, that said mail in there. And I think it even had it already uppercased. But you call to uppercase, and you end up with an I with a dot on it, or something like that, because Turkey's interesting like that. And these days, there's a page called the Turkey test, saying, if you want to find out whether your code works, you should switch to the Turkish culture and try it in that for a while. Because you get this problem. I'm not quite sure whether it's only Turkey and only the I. I think it might be. But basically, when you're comparing something in a case-insensitive way, certainly in .NET, you use the thing that says, I want to compare it case-insensitively, and in the current culture, or the invariant culture, or in ordinal form, which means slightly different things that you need to learn about. But yeah, we had a call, and it took me a long time to work this out. Here's another bug. This one wasn't my problem, but it was before, there was a time before Stack Overflow, okay? I hate to break this to you, but back then, I used to hang out on the Java news groups and the C# news groups. And someone had this bit of C#. I apologize for the lack of syntax highlighting. And the bit, let me just, the bit there, the top one is 2 spaces. That's 2 spaces, that's 1 space, okay? So this is meant to be an inefficient way of collapsing white space. And not just any white space, but just spaces. That's all they needed to do. It wasn't intentionally poorly performing, that's just a byproduct. Can anyone guess what happened when they ran this code? Pardon? 1 space? What, they ended up with the wrong answer? Okay, no, they didn't end up with the wrong answer, which is, pardon? It cycled. Yes, it did. It went into an infinite loop. Can you tell me how it did so? So let's imagine we had 6 spaces. So text.index of, say it's A, 6 spaces B. So index of would be 1. We replace double space with 1 space, and we end up with A, 3 spaces B. Go into the loop again, fine. Yep, still index 1. Replace double space with single space. We end up with 2 spaces, because we've got a 2 then a 1, so that becomes a 1 then a 1. Go in a 3rd time, and it collapses the 2 space to 1, and we get the right answer. So it's not quite like that. This is the string that broke it. You see that nasty little 200C? That's an evil character called the zero-width non-joiner. And the interesting thing is that index of will ignore it. So index of sees a space to that side of it, and a space to that side of it. My laptop just went bingle, and I have no idea why. That's really worrying. It may have decided that it's about to do the Windows Creators Update, in which case I might have it back in time for tomorrow's talk. We'll see. Anyway, so index of says, oh, there's a space followed, oh, I'll ignore that. There's another space. So the index of isn't -1. Replace says, oh, well, I can't find any 2 spaces together, so I'll just return you the original string. Let's go back into the loop. And index of finds the 2 spaces again. You can see where I'm going. I've just remembered that I wrote this talk before I became aware of my favorite Unicode character. I've blogged about this before, but there's a character, I've tried to adopt this. I don't know whether you know that Unicode has an adopt a character program, basically to raise money, where you can say, I want to adopt the Unicode snowman, or the Unicode pile of poo, or whatever it is. I wanted to adopt the Mongolian vowel separator. This is a wonderful character. I will get the history wrong, because I've got it in a different presentation somewhere, but it was introduced in Unicode 3, I think. And it was introduced as a formatting character. Again, I've read the description of what this character means, and it's something to do with what happens at the end of a word in Mongolian. And I'm sure it makes perfect sense to people from Mongolia. It makes no sense to me. But it was introduced in Unicode 3 as a formatting character. Then in, I think it was Unicode 4, they said, no, it shouldn't count as a formatting character, it should count as white space. So it was white space until I think Unicode 7. Then they said, do you know what, we got it wrong, it really is a formatting character. Bingle again. The reason this is particularly interesting to me, as a C# nerd, is that you can have identifiers, so variable names, that contain formatting characters. So you could have a variable called string Mongolian vowel separator X. And in Unicode 3 and Unicode 7 afterwards, that piece of text would be one identifier. In Unicode 4, 5, 6, if I've got my history right, it would count as white space, so it would be string space X. So it would be declaring a variable called X. Fortunately, of course, the C# specification says which version of Unicode it targets. And so does the ECMA standard. It's a shame that they specify different versions. It's all right, we're fixing that, because I'm the convener now of the ECMA C# Standardization Committee, and we're fixing it to not say which version we're targeting. Which isn't quite as crazy as it sounds, because basically we're all using Roslyn now, right? And Roslyn will use whichever version of Unicode is in .NET or .NET Core that it's running with. It used to be that CSC, the old native compiler, shipped with a version of Unicode built into it. Unicode 2, I think. So I have a program that should give different results based on mono, which implements the ECMA standard, or the old CSC. I've never quite managed to get mono to quite work to do it. But that's why the Mongolian vowel separator is my absolute favorite character. So, text turned out not to be terribly easy, I think you'll agree. Next, we come on to my favorite topic, date and time. I see some of you have used date and time before. This is where I will actually go into some detail, partly because I know something about it, and partly because this is an hour-long keynote, and the original presentation was half an hour. So, you know, I wanted to go into some depth, and actually, this is the bit of the presentation where you may learn something useful instead of about the Mongolian vowel separator. I hope there will be two results from this. One is that half of you will go and start using NodeTime as soon as you possibly can. I'll explain what NodeTime is in a minute. And everyone will start thinking about dates and times in a more disciplined way. No more, I'll just use that and hope it's the time zone that I wanted it to be. You know, we'll come to it. Okay, so I'm biased on this whole front because I've done more date and time work than most developers. This is not a boast, it's just the way things have happened. This was already the case back in whenever it was. I think it was 2010 that I first gave this. I had been working, still in Google, on something called ActiveSync, which is the protocol that Exchange uses. And when I first joined Google, I joined the mobile sync team. Do you know what, Tony? I think I've asked you enough questions now, and my hand's getting quite hot. So if you could just give Tony one round of applause, and he can go and have a rest. I don't know why you need a rest. You weren't programming with Roslyn at 4 in the morning. Anyway, oh, that's better. Right, another bingle. So I was doing things with the mobile sync team in Google London, and the iPhone had recently come out. We'd previously been focusing on SyncML, but suddenly the iPhone was out, and people seemed to think it was kind of a big deal. And it had the ability to synchronize mail, calendar, and contacts with an Exchange server. And it would do this via ActiveSync, the ActiveSync protocol that was not quite open at the time, but you could pay Microsoft, you could license it from Microsoft and stuff. So we sort of moved our focus towards this active sync protocol. So at this point, we've got Google implementing a protocol designed by Microsoft primarily aimed at Apple devices. And in fact, that triumvirate of pleasant technology companies wasn't where the problems lay, mostly, although birthdays, oh, give me strength, the way that birthdays are represented, not a good idea. But I may give that as an example later on of what not to do. I mostly had problems implementing time zone detection for devices that had clearly been programmed by people like Tony. How many of you are familiar with base 64? Just vaguely familiar? Yeah, a smattering. So base 64 encodes arbitrary binary data. This is what you're meant to do instead of saying, I've got an encrypted image, I'll just use UTF-8, that'll be fine. You're meant to use something like base 64 that encodes every 3 bytes into 4 characters. Seems reasonable. And if you happen to have a message of whatever kind that isn't a multiple of 3 bytes, you put equals characters at the end so that it rounds it to a 4-character boundary. We saw one mobile phone manufacturer who had implemented base 64 themselves, because why not, why use something that someone else has done and tested when you can write your own? And they'd seen that there was this padding at the end, but they just thought, well, if we always add 4 equal signs at the end, that'll always be enough. Where is your clue? And that's before you get down to the time zone, how the time zone is meant to be represented. The time zone representation in ActiveSync is not a particularly pleasant one, so it assumes that either you don't observe daylight saving time at all, or you have 2 daylight saving time switches per year. You go into daylight saving time, and you go out of daylight saving time. So there's a way of it saying, well, you go into daylight saving time on the 3rd Sunday of March, and you come out on the 2nd Sunday of October at this time of day. And, okay, it doesn't give you any historical accuracy. That's one of the problems. And it doesn't help if you're in a country that goes in and out of time zones, in and out of daylight saving time multiple times in a year, which does happen. But it's reasonable. Except that some people decided to implement it by either only giving one of those transitions. So they said, we go into daylight saving times in March, and that's all I'm going to tell you. The rest of the fields are 0. Or the other one that decided to use, it's not a nice representation for how they say, the 3rd Sunday, but basically, this phone decided to encode the actual date that it was going into daylight saving time this year and send that as the time zone, and the actual date that it was coming out of it. Which meant that if you were around New Year, you didn't know whether the phone had sent the message thinking it was 2015 or 2016, so you had to kind of try a couple of things. So I had a heuristic time zone detector. It was, what on earth time zone do we think that this phone thinks it is? Oh. Looking back, I've just told you horror stories, and yet I decided to do more date and time work. I don't quite understand why. Then there was the time that I got into work, and our integration tests have failed overnight because it had rained a lot in Argentina. It's the only weather-related unit test failure I've had, but basically Argentina decided that because there had been a lot of rain, they didn't need to go into daylight saving time because they believed that daylight saving time helped save power, but they had a lot of water in their hydroelectric dams, so they decided not to bother, if you see what I mean. And they decided this with a couple of weeks of notice. So we had something that knew about this change and something that didn't, and my code thought that the phone was in Greenland. as it happens, that did find a bug, because there's no way that I should have thought it was in Greenland, right up here, instead of Argentina, right down there. But it was still kind of annoying. I will come back to date and time trivia as we go, but I should actually give you some information. So I gave this presentation and bemoaned the state of date and time libraries. I had been working and had wisely chosen to use JodaTime as much as I possibly could. This was long before Java 8 and Java.time, which is what you should use now, by the way. So I bemoaned the fact that on .NET, we only had date-time. And I think date-time offset had just come in. It's kind of new. We might have had time zone info instead of... Anyone remember the time zone class? Where the only time zone you could get was the system local time zone. What's the point of that? Time zone info is a lot better. It's only really bad instead of truly terrible. But I thought, isn't it a shame that .NET developers don't have JodaTime? I know I will start my own .NET date and time library that's based on JodaTime. And so NodaTime was born within a week of this. And I don't mean there was code within a week. I mean there was a name within a week, and probably a project on Google Code. It took me about 3 years to get to the first release, and we recently released version 2. We've had minor releases in between. Out of interest, just so I know whether I'm preaching to the choir or the unconverted, how many of you have tried NodaTime? Oh, that's not bad. And are still using NodaTime? Fewer. I would be really, really interested if you could tell me later on why you're not using it, whether it's because I've messed up or because it's you'd love to but you can't for whatever reason. My point is that date and time is hard. I'm going to ignore this, which is my best effort at representing relativity. So, the lamp is traveling at light speed, and still the light is traveling at light speed ahead of it. I don't know relativity. I did maths at university, and I should understand it to some extent, and I just don't. It is a mystery to me. I'm also going to ignore leap seconds, because I think almost everyone here does. How many of you are writing code that will be used in GPS satellites? One. Okay, you need to care about leap seconds, probably. The rest of you don't. Sorry. And if you want to use NodaTime, sorry. I don't support leap seconds. Any sensible library, unless it's aimed at the very niche field, will not support leap seconds. Java util date. How many of you, I know this is a .NET conference, but how many of you have used Java significantly? Oh, you lucky people. You haven't experienced the horrors of Java util date and Java util calendar. They're really good classes, actually, for demonstrating API fail. They're the gift that keeps on giving. Every time you think you've reached the bottom, you find something else that's wrong. But anyway, Java explicitly states that it might or might not support leap seconds, depending on the underlying support in the operating system. So, it's good to be predictable with our software. I'm going to pretend they don't exist. Let's have a look at this and see what it can tell us about the problem that is date and time. So, this has incomplete information. It shows that it's about 3:05, and we can probably guess that it is day 20 on month 9 of year 2013. Does that mean it was just under 4 years ago? Not necessarily. If you assume that, you're probably assuming that this is the Gregorian calendar. It could be one of the many Islamic calendars, it could be the Japanese calendar, it could be the Julian calendar, which would only be subtly different. Who knows? And we also don't know whether this is AM or PM. We don't have an indicator. We're quite lucky that we've got a 20 there. Imagine that had said 5/9/2013. Would that have meant May the 9th or September the 5th? So that's one problem already. And this is a problem which has definitely been caused by people, mainly Americans. I mean, that's not strictly... yeah. For American, is this being recorded? Is this going to be seen in America? I love you, really. But no, Americans do have the most interesting way of representing dates, don't they? You know, it's, yeah, let's put the month first, then the day, and then we'll go back to year. What I think of as the British way, only because I'm British, I don't know, how do you represent them in Russia? Same, right, so day, month, year. Yeah, so at least it's kind of consistent. It's wrong as well, in that clearly you want dates to be sortable, so the ISO standard of year, month, day is definitely the way to go, and the good thing is that that isn't going to be ambiguous, unless you're dealing with dates in the year 12 or whatever. That's not going to be ambiguous between an American reader and a European reader, or Russian, or etc. I think there are a few other places that use the American format, but precious few. But yeah, there's no benefit in having these different formats. Okay, I can see why we've ended up with different formats for writing. You know, humankind has evolved in many different places, writing evolved many different ways. Surely we could have got together on how to represent dates. Okay, it's not that hard. And surely we could have done better than this as well. Anyone care to tell me what these are? No, they're not. It's a bit of a trick question. So the answer that I was saying, no, they're not, is time zones. They're sort of time zone abbreviations, but they're not time zones. So I'm not sure which time zone we're in here. At home, I'm in the Europe-London time zone. And a time zone, I'll come on to that. I've got a pretty picture for you later on. But these are time zone abbreviations that aren't really time zones. And can anyone see anything kind of interesting in this set? UTC, that is definitely interesting, because UTC is not, at least strictly speaking, a time zone. Purists will tell you that it's not. It's sort of a point of reference. For all normal business intents and purposes, think of it as a time zone. The reason it's not is a time zone is sort of associated with a particular geography, and UTC isn't. But, okay. What I'm interested in is, this has got, oh yeah, that's on now. So we've got CST up there, CST down here, and CST over there, which are Central Standard Time in the United States, Central Standard Time in Australia, and also Central Summer Time in Australia. I shouldn't laugh too much, because I've got BST there as well. BST, all my British friends will tell me, means British Summertime. And usually it does. Apart from between 1968 and 1971, when it meant British Standard Time. It was still UTC +1, but we went into UTC +1 permanently, so it wasn't daylight saving. So this BST could represent something with daylight saving time or not. Oh boy. This is all a mess, you'll agree. I want to give you, in 10 minutes, a quick rundown of how to think about time. Okay? Even though it's a mess, and even though the standard libraries are terrible in most languages, and they're a lot better now than they were, mostly because java.time is much better than previous versions. But even if you're using a bad library, if you think about time really clearly and document and use sensible variable names, please use sensible variable names, and think about what you're trying to represent, you can do it. So, first concept. This will be fairly quick, but I gave a longer version of this talk at CodeMash, and hopefully the video for that is online. So if you want more details, watch that. An instant. So this dot there represents an instant in time. This is the timeline. Is it January, May, whatever? No. There's no calendar system associated with this. This is just pure time. This is time as a computer would see it. Time as God would see it, if you want. It's just linear, because we're not dealing with relativity and stuff. And the way that we deal with it in a computer is to say, well, we'll think about some instant as an epoch, and all we need to measure is the number of milliseconds or nanoseconds or seconds or whatever it is between that epoch and now. And when I say instant, the way I like to think about it is, suppose you're on a hangout with 5 different people around the world. And suppose you've also got an infinitely fast connection, okay? They could be observing different calendars and have different time zones. They're living in different time zones. But if I click my finger, if I do it nearer the microphone, it picks it up. We would all, if we were recording the instant, we would all record the same value, because it doesn't depend on the calendar or the time zone. It's pure. This is what you use for timestamps, okay? Moving on, these are durations in time. So you can see I've said that they're equal. What that means is these 2 lines have equal length. This is represented in .NET as time span. There's no concept of a month as a time span, because months can vary in length. This is a fixed length of time. You could shift this line along the timeline, and it wouldn't change in length. And it's also floating in terms of, it's not anchored at the epoch or anchored at any one particular time. It's just 10 milliseconds, or however long it is. You can anchor things, and you get intervals instead. So the interval between S1 and E1 is not the same as the interval between S2 and E2. Because you could ask an interval, what is your starting time? What is your ending time? And it would give you an instant in each case. Okay? So that can be very useful if you want to record the timestamps when a particular job started and stopped. You naturally have an interval. And the length of an interval is a duration. Things start getting less pure when we bring in calendar systems. So calendar systems are ways of breaking time up into years, months, and days, typically. There are some really obscure calendars that have different ways of doing things. We'll not worry about those. Note there's no time zone on a calendar. This was one of the mistakes that JodaTime made. There's no time zone on a calendar, so when you have a date on a calendar, well, that's January the 19th. You could have 2 different people on a phone line, and if you said, what is today's date, one of them could say January the 19th, one of them could say January the 20th, because they're applying their local time. When we've got the idea of a date without a time zone, it's obvious to have a time without a time zone. It's currently 11:22 here. And I don't need to explicitly say the time zone for us all to agree that within our local context, it is 11:22. If I set my alarm, I have my alarm on my phone set to wake me up at 6 o'clock. It woke me up at 6 o'clock in the UK. It wakes me up, normally when I'm not playing with Roslyn, at 6 o'clock here. That 6 o'clock is a local time. If it were anchored to a particular time zone, then it would have woken me up at 8 o'clock when I was here, if it was 6 o'clock in the UK. So this doesn't have a time zone. Put those 2 together, and you get a local date and time. Things get more complicated when we bring time zones in. So a time zone is a mapping. You can look at it in various ways. I like to think of it as a mapping between the instant in time on the timeline and a local date time if you apply a particular calendar system. Or if you don't want to apply a calendar system, you can just say that it's a mapping from an instant in time to an offset from UTC, in which case the graph would be sort of horizontal and then go up a bit and then go, so this is you going into daylight saving time, and then at some point you come out of daylight saving time. And the fact that it is both of those, one may be UTC plus 3, one may be UTC plus 2, that's why CDT isn't a time zone. Because if you're in the central time zone in the United States, you will vary between CST and CDT, but you're only in one time zone. I don't have enough time to do justice to this, but it is feasible. I can almost see half of you thinking, time zones are just too difficult for me to understand. They're really not too bad. It's taken me years to work out that they're not too bad, because humanity has made a hash of things, but it's still just about feasible. Partly due to the hard work of, in this case, people like me writing Node at time, and a group of volunteers who maintains the time zone database. Forget about Windows time zones if you possibly can. Use the IANA time zones. It's manageable. There are difficulties, but it's manageable. So when you have a zoned date time, that is a particular date and time in a particular time zone, and potentially what I haven't shown on here is an offset, because it wouldn't happen for this particular date and time, but if this said something like, I should really know these off the top of my head, but something like the 26th of March, 2017, at 1:30 in the morning, that didn't actually happen. And the corresponding one in October, the 1:30 in the morning could happen twice, because we go up to 2 o'clock in the morning and then fall back to 1 o'clock. So you get 1:30 happening, and then it happens again. So just looking at your watch does not uniquely identify an instant in time, even when you've got a time zone. So anytime, and this is one of the problems I have with the .NET time things, anytime you're trying to convert from a local time in a particular time zone to UTC, to find the instant, you've got to think, well, what happens if the date and time that I've given didn't happen at all or happened twice? What do I want to do? Node time forces you to say what you want to happen. So you can say, convert this in strict mode, which is, if it's ambiguous or skipped, just throw an exception, because I really haven't dealt with it. I don't think it'll happen, and it's better that I go bang than record incorrect data. There's lenient mode, which is, oh, go on then. It does say exactly what will happen, although that changed between version 1 and version 2. That's fine, semver, breaking changes. Or you can specify your own rules. So you can say, well, if it didn't exist, then call this delegate that will return whatever you want it to return. It could return the instant before, the instant after, 3 days later, who knows. And likewise if it's ambiguous. But you have to choose. The final concept, 2 concepts actually. This is an offset date time. So this -8 over here is not a time zone. I don't care how many times ISO 8601 refers to that as a time zone, it is not a time zone. That tells me the local time at 9 o'clock on the 1st of January. Sorry, the 19th of January. It doesn't tell me what the time will be 1 minute later, because it's not a time zone. So if someone observed and recorded that, then a minute later it could be 10:01, because they might have some weird time zone that transitions at 9 o'clock and 30 seconds, it goes forwards an hour. Seems unlikely, but it's feasible. So offset, not a time zone. And finally, I mentioned before that a duration can't be a month, because a month varies in length. But it's useful to have the concept of a month or a year. We earlier talked about whether someone was 18 years old or not. Again, years are variable in length. So isn't it nice to be able to do arithmetic and say, well, I was born on this local date, please add 18 years to it and tell me what you get. So this is a period. So just to wrap up, those are 7 or 8, something like that, concepts in a field that feels more complicated than text and numbers, because we're used to, you get round some of the corner cases of numbers and text, and you're mostly going to be okay. If people enter loads of emoji in their name field on your web app, maybe they have a hard time. Meh. But you're mostly okay. With date and time, there are so many corner cases, just the whole field is full of corner cases, and you go wrong really easily, which makes it feel like it's very, very hard to do the right thing. I would say this is much easier to do the right thing than text, but you need to work at it. So I would really urge you to spend an hour. How many of you have wasted more than an hour trying to track down date and time problems or time zone issues before? Yeah, quite a few of you. So spend that hour up front so that next time you're writing some code with dates and times, you know what you're doing. You know, I can identify, right, this variable represents an instant. Okay, I'm using date time, but because I've got to for whatever reason, but I'll make sure that it has a kind of UTC, I will do the right thing, I will treat it as an instant. This one, I will treat as a local date time. I'll have a kind of unspecified and do the right thing. So really invest an hour. But I want to sort of step out now and think back to the overriding themes of the talk. So fundamentally, we failed. Computing has failed. It's amazing that it still works, but we have failed to make simple things simple. We failed because users have different ideas and because basically the world is complicated. Sometimes those complications, like with language, are natural. Sometimes, as per date formats, there's absolutely no reason why it should be as messed up as it is. We failed because architects built Java util date and Java util calendar and the like. They tried to model something that was complex, and they did a bad job of it. We all do bad jobs sometimes, which is why I've also blamed developers. Yep, I'm there. Final slide. So if that all sounds doom and gloom, don't worry. It is feasible to do the right thing. I would urge you to always learn one level lower than you think you need. Never need to do Unicode normalization? That's fine. Learn just a bit about it. Learn enough so that when you feel you're at the edge of where you need to understand, you know that you're there. Use the right libraries, use the right tools for the job, and you can succeed. This is probably the most basic building blocks talk of the conference. You'll spend the rest of the time thinking about much higher level concepts. But I want you to go away and just remember how we've messed everything up and just be incredibly glad that anything works at all. Thank you very much.